So here is the big one. This is the big video about this whole kind of unit. I would love to give you a kind of story about Darwin and who he was, but he is the father of natural selection. You can watch some pretty cool clips. I might put some in our playlist so that you can watch some history about Darwin. If we've got time in class, we'll watch them there too. But for now, I just want to go through the theory of natural selection, because Darwin himself is not part of the course, which is a bit sad. We go through theory, but not Darwin himself. So I have, over the past few years, broken down this theory of natural selection into 4 kind of main points to make it a bit easier to remember. And then you should be able to look at almost any scenario, and I've got a whole bunch for you to look at, and apply these 4 steps and see where you can link them in. And therefore, it's going to help you with any kind of natural selection question you come across on an exam. So when we look at our big dot point, here's a dot point. Again, we've already covered the types of mutations. We're not needing to cover chromosomal abnormalities. We've already covered selection pressures. And so therefore, we're now going to look at the theory of natural selection. So it's kind of hidden in this massive dot point, which is really annoying, but we can pull it apart anyway. So natural selection is this whole process that drives evolution. And it starts off with these set of steps. Yes, I'm going to break these down. So the first one here has got to do with variation. Then we have selection pressures, which we just talked about. Then we talk about nature selecting the phenotype, so selection. And then the last bit is about reproduction and passing things on. So we're summarizing it into these 4 main steps. These are the words that I want you to write down. We can come up with a mnemonic for them. So we go with variation, start first. You have to have variation. Then we go for a struggle for survival, or there's going to be a selection pressure that acts upon things. There has to be someone that has a selective advantage in your population. And then the last bit has got to do with inheritance. So 4 stages, 4 dot points. Any natural selection question, come back to these things. So we've got variation, selection pressure, selective advantage, and then inheritance. Bang. So let's have a look at the first one. Nice and easy. There need to be differences in the number of between the members of the species. So this could be, e.g., purple versus orange spikes. Yeah, I'm just going to say any kind of characteristic. It doesn't matter, but there has to be more than one. If every single individual is exactly the same, natural selection cannot work. The biggest thing is that variation must exist, and it must exist at the beginning. All right, so the next thing that needs to come into play, and this is perhaps a little bit less important, but it's still part of it, is that you need to have too many individuals. There needs to be a drive for competition. You can't just have families existing and there's no kind of fight over resources, there's no fight over space. So there needs to be more individuals being born than are actually needed by the environment. So this overproduction continues, and so they keep having more babies than can be supported, and that means that we end up with a struggle for survival. Okay, so now there's a difference there. There has a struggle for survival. So this could be caused by a selection pressure as well. So the selection pressure could come in. There could be a new predator, for example, and therefore there are too many of an organism around, and we need to cull some. So you've got variation, we've got a struggle for survival. The next step that comes along is some of those individuals are going to be better suited to the environment. These are the ones that have what we call a selective advantage. So say the environment ended up being a bunch of trees. Yeah, a new predator comes along and it's a ground dwelling predator. So any organism that has the ability to climb a tree, they are going to have the selective advantage here. Any organism that stays on the ground, they have a selective disadvantage. So there has to be something, a variation that gives someone an edge compared to other people. So favorable traits are the ones that we say are selected for, and detrimental or less favorable traits are what we call selected against. All right. So after you've had this struggle for survival and unfortunately things die, or at least they have to in order to be successful in Darwin's terms, you need to be able to reproduce. Okay. So this variation that you had in yourself needs to be able to be passed on to your offspring. So it's not something you gain during your lifetime. It's something you are born with. It gave you an advantage, and as a result, you can pass it on to your offspring. And so this is my last point here, is to say inheritance. So there's a change in allele frequencies over time, and that's more evolution. But the process of natural selection has got to do with, there's variation that's genetically inherited. You get some kind of selection pressure that's going to act upon that. You end up with certain individuals having a selective advantage to others, and those are the ones that therefore are successful, and they reproduce. And this is the other bit. They reproduce, and I'm going to say to pass on their genes to their offspring. Okay, so it's not just traits, but they're going to pass on their great genetic material to their offspring. Without doing that, then the trait isn't going to change. So here's a really good example. These are called peppered moths. Now, what I'm hoping to find for you guys is a bit of a simulation to show you what happened with the peppered moths. But prior to the Industrial Revolution, so prior to the Industrial Revolution, we had about 80% of these guys, of these white moths, and only 20% of the black moths. That's because the trees were covered in lichen, which is it looks very, very similar to this. So what would happen is these moths both would exist. Can you see the other one here? So here's the black moth. Yeah. So these moths would both exist. So you've got a peppered moth and a black moth. These peppered moths would land on the lichen-covered trees and they would blend in. The black moths would land on the lichen-covered trees and they would stand out. And so birds would come along. Which one are you going to eat? You're going to eat the one you can see more of. So you're going to eat the black peppered moths. Even though I say they're peppered moths, they are still the same species, just some of them are black. So before the Industrial Revolution, all these lichen-covered trees, the peppered moths were the ones that had the selective advantage. So these guys had the selective advantage prior to the Industrial Revolution. So what I'm hoping, oh, sorry guys, what I'm hoping is that I can change my color. So after the Industrial Revolution, what we saw was about 2% of the peppered moths and about 98% were these black moths. So after the Industrial Revolution, you get all these black moths coming around. And the reason these black moths are coming around is because what's going to happen to these lichen-covered trees? These lichen-covered trees are now going to be covered in soot. Now, when they're covered in soot, they become black. So you've got these soot-covered trees. Now, all of a sudden, the black moths are blending in. So the black moths have the selective advantage. And the white peppered moths stand out like this picture right here. So if they stand out, what are the birds going to come along and eat? They're going to come along and eat those peppered moths. As a result, you get a massive shift in the population of moths that are around. So natural selection can act. Normally it acts over quite a big period of time, but with organisms like moths that have very quick reproductive rates, you can see natural selection happening. And this happened in about 50 years. Yeah, so it only took about 50 years for the population of moths to change from 80% white moths to 98% black moths. Yeah, and that was due to that massive selection pressure of the trees being covered in soot, and so therefore the white moths are being predated upon. That was their selective disadvantage was the fact that they were obvious. The black moths reproduced, passed on their genes, and therefore you get lots more black moths. Another example that you can see, or that we have seen in the last, this one's less than 50 years. Oh, sorry guys. This one is, that's helpful, isn't it? Less than 50 years. I'm not even sure how long this took. This is what we call MRSA, which is methicillin or multiple resistance, depending on which doctor you're talking to, Staphylococcus aureus. It's an infection caused by a bacterium. So you get a bunch of bacteria. Yeah. So to begin with, we have variation in the bacteria. You have most of the bacteria are normal, but then some of the bacteria are resistant to antibiotics. Now what happens is you bathe them in antibiotics. So this becomes your selection pressure. Your selection pressure is that you start trying to kill off all your bacteria with antibiotics. Now the problem is it'll kill all the non-resistant bacteria, but these guys, these resistant ones, they have the selective advantage. And so what happens is over time, they multiply and become more common. So we get inheritance and the passing on, and eventually all of the bacteria are resistant. Now, this is pretty dangerous in the context of a hospital, because in the context of a hospital, if you can't kill off bacteria with antibiotics, then they're just going to run rampant. And in particular, this is pretty dangerous for people with compromised immune systems. It's dangerous for elderly people. It's dangerous for people that have open wounds. And what do you find in a hospital? All of these things. So instead of this being an issue, what we've done, and this is driven before the times of COVID, we've actually been able to clean the surfaces, employ much more rigorous hygiene practices, and therefore try and eliminate this. But occasionally we still get outbreaks of this methicillin resistant or multiple resistant Staphylococcus aureus in hospitals. There's a whole bunch of very cool videos that I'm going to put in our playlist, and make sure we watch a couple in class too. So that should be a bit of a summary on natural selection, and there are lots more examples that we can go